Here's some helpful hints on this worksheet. Feel free to skip ahead if you don't need help on this particular problem. Great, so I want to just start out with once again talking about the equations. This first equation right here is, let's see, we're going to sketch on this one. This equation is if you need to find the position of something. So if you're looking for where it is, how far it's gone, the distance traveled, something like that. Also, this equation down here is also useful for finding position, and I can show you all a trick in class about it. This term right here means average velocity, so we'll have to remember about that. But more or less, if you're finding the position, you're going to use this equation, right? But also remembering that it can simplify greatly to this equation here if you don't have an initial velocity. So if your initial velocity is 0, and if your initial position is 0, then it simplifies greatly. So there's those things. If you're looking for how fast something's going, so it says, what's the final speed? What is its speed at? Then you're going to want to use this equation here. That's going to show you how fast something's going, acceleration in time and initial velocity. And then if it's asking you what's the acceleration, then this equation here is going to be for acceleration, and you need change in velocity divided by time. One thing I want to point out is that in that change in velocity at the top right there, you need to do final velocity minus initial velocity. So your acceleration could end up negative. Okay, great. So just going to point out some things right here on some of these problems. First of all, if I'm asking what's his acceleration, I'm going to use the acceleration equation. When you're finished with that, your unit should be meters per second per second. Let's see if that all shows up. Oh, this annotation's terrible here. I'm very sorry, it's just really slow. Okay, so we got to get rid of all that. Meters per second. No. Okay, well, you just have to hear what I'm saying. Meters per second for what is his acceleration. And down here, we're asking once again, what is his acceleration? Okay, good. So once again, you're going to do change in velocity. So there's your initial velocity, and there's your final velocity. So make sure you're subtracting your initial velocity and your final velocity. Okay, I guess I don't need to erase those things. Here's this question, how far does a car travel? You're going to want to use the x equals equation. So a lot of times in physics problems, you need to do one thing first, and then you have to do the actual problem. So first, you're going to use the acceleration formula up here, this acceleration formula, and you're going to find the acceleration, and then you're going to use that in the position formula to find the position. Okay, moving right along. So once again, if we're looking for what its final velocity will be, you're going to use the velocity equation. So up here, there's the velocity equation, just like that. Okay. Find the distance the Ferrari went. So you're going to use the distance formula. That's the x equals formula. I just shouldn't even try to write words. Okay, the x equals formula. And you have the acceleration. So here's the acceleration. You have an initial velocity. You have a time. So you have to plug a lot of things into that x equals equation. Okay. This one right here, how far does the lizard travel? One thing to pay attention to is that your final velocity here is less than your initial velocity. That means that your acceleration is going to end up as a negative number. That's totally fine, it just needs to stay negative. So up here in this this position equation, that acceleration is going to be a negative number. In this problem, you do have an initial velocity. And in almost all these problems, you don't have an initial position. So once again, down here in this problem with a lizard, make sure your acceleration is negative, and make sure you include your initial velocity. Okay, how far does the car travel? That's a position. You're going to want to use the position formula. First, you're going to have to find the acceleration, and then you're going to have to find the position. This one is like kind of a brand new problem. So what's happening in this problem is you're starting out with a car. It has an initial velocity of 40, and then it slows down and stops. Now, if you're looking at a version of the worksheet, I may have made some changes, and I think I added stops in here to a later version of the worksheet. So once again, in this problem B, you have an initial velocity, and your final velocity is 0, and then there's your time. So first of all, you have to figure out what is your acceleration. So you're going to find your acceleration, keeping in mind that it's going to be negative, because your final velocity is 0, and your initial velocity is 40, right? So it's going to be a negative number. And then how far does it go? You're going to have to use the position formula, x equals, with a negative acceleration, and you have to add in an initial velocity, right? So don't forget about all those things. It's a kind of a complicated formula, but you can do it. Okay, for these problems, for number 9, they're all asking how far apart they will be. So you're going to have to do 2 different x equals equations. So what I would do is I would set up an x. Is that going to work for me? Okay, x. I did an x. Okay, good. I would set up an x for the red car. Oh yeah, good, that worked. And I would set up an x. Oh, not happy. Let's try it again. I would set up an x for, oh man, okay. Well, oh boy. All right, set up an x for the red car and then set up an x for the blue car and then find them both out. So this one you have the acceleration of the blue car and you have the acceleration of the red car, right? So just set up an x equals equation, same amount of time. Down here for this one, so once again, you're going to set up an equation for the red car and for the blue car. This time it says find the time it takes for the blue car to go 18 meters per second. So how do I do that? I have a car starting at rest and ending at 18 meters per second. How do I find the time? We'll come back up here and look at these formulas. There's an equation we can use that relates together acceleration and change in velocity and time. Or you can use this equation as well. Same equation, it's just written in a different way. So if you have your change in velocity and you have your acceleration, then you can find the time. Okay, so you've got to solve for the time. Once you have that time, you can plug it back into this position formula. Right, so the questions get a little harder as we go along. So that's this one, find the time it takes. Now for part C, once again, how far apart will they be? Write an equation for the position for R, for the red car, for the position for the blue car. This time, when the red car has traveled 80 meters. Well, you already know the red car's traveled 80 meters. So in this one, you don't need to set up an equation for the red car, but you do need it for the blue car. What you do have to do first is find the time it takes the red car to go 80 meters, right? How do I do that? Well, I've got a formula up here that relates together position and acceleration and time. And if I know that the position's 80 meters and I know the acceleration, I can find the time. Just use a little bit of algebra to find the time. Then use that time to plug back into this formula for the other car. Okay, so there's some hints on those problems. The buggy and the pullback truck one, let's just forget about this one for now because we're going to do it actually in class. We're actually going to do the buggy versus pullback truck in class. So let's skip that one for now. Okay, so this one I may have made a slight change in the directions here depending on which version of a worksheet you got. So I think you can figure this out. And what I'm saying here is sometimes this formula can't be used and sometimes this formula can't be used directly because you don't know the time. And sometimes figuring out the time is an extra step. So let's get rid of those 2 things. What we can do is actually use this handy formula right here. And this always works, but it actually goes by the average velocity right there. Oh, that kind of pointed to the T instead of the V. So it goes by this average velocity right there. Sometimes the average velocity is actually pretty easy to figure out. For example, in this problem right here, you start at rest, that's 0 velocity. You end up at 300 meters per second, and you can find the average between those really easy. The average between 300 and 0, you can figure that out. Once you find the average velocity, if you know how far you've gone, which I do in this problem, I know it's 100 meters. So there's how far I've gone. I can use that for x. Oops. I can use that for x, 100 meters. Now I know my average between these 2 things is going to go in for my average velocity, and then I can find the time. So that's what's happening down here. It's saying use those to find the time. Once you have the time, then you can go back and use this formula to find the acceleration. It's going to be unreasonable because it's a rocket ship, right? And it's getting up to 300 meters per second, which is like 700 miles an hour in the length of a football field, right? And then I just want you to compare. Now I also changed some things on this one. I made a mistake in this in an earlier worksheet version. So it might say method from problem 9, but this is the same problem. You're going to find the average between 50 and 10. I think you can find the average between 50 and 10. That's pretty easy to do there. And then use this method up here. What's the method? Find the time and then use the 1/2 AT squared formula to find the, find the acceleration. Oh, that's all I did. So all you need to do is find the acceleration. That's it. So you're going to use this formula to find the acceleration. All right, hopefully that is helpful for you. Once again, bring your questions to class, and I will see you soon.